Alright, today we're going to go over finding the areas of parallelograms and triangles. We have done this earlier in the year, but there was just some things that I wanted to make sure that I clarified, because when we move into finding the volume of shapes and surface area, we're going to need to remember some of these things. So area of any type of parallelogram, rectangle, square, anything like that is always going to be my base times my height. What we need to understand, what we didn't do well of the first time we did this, is that the base can be any side. Any side. I would rather write the formula as area is equal to a side times the height. So the problem is that we always think of base as the bottom. It does not have to be the bottom. That's why in every single one of these problems I have tilted the picture so that we have to see a side and then the height that is perpendicular to the side. So any side I can choose. Again, side, any of them. Any side will always have a height, a line that I can draw that's perpendicular. And again, my height always has to be perpendicular to the base. So with this first problem, I think it's easier to identify the height. So this 4 right here is my height. This is going to be my vertical piece of this shape. And then I just want to see what side is going to be perpendicular to that height. And so I'm just looking to make a T. And so right here I can make a T with the bottom right there. So these two, the side and the height are perpendicular to each other. So I know that my area is going to be 5 times 40. Just my base times my height, and so my area is equal to 20, and then these are square inches. With the second one, same type of problem, you have the same shape. What I want to do here is I want to find out what this height is right here. And so again, I'm going to kind of draw that. And so the side that is perpendicular to that height right there, again, looking for that T, is going to be this side right there. So I know that those two go together. And so I know that the area will be equal to 0.5 times whatever h is my height. Since I have two variables there, I can't find out what h is because I don't know what the area is. So I can use the other two pieces, the other side and the side that goes, or the height that goes with that side. And so I can take this 0.3 and I can move it inside so I can get a better picture. So I move that side inside of there and I get 0.3. Again, this guy right here and this guy right here make an L, but again, T, same type of thing, they're perpendicular to each other, and so those two, the ones that I highlighted in green, go together. So I know that my area is going to be equal to 0.3 times 0.4. And so this one, I can find out what my area is because I have two numbers. It's going to be 0.12. And then I can take this and I can plug it in here because it's the same shape, so I know that 0.12 is equal to 0.5 times h. I can divide both sides by 0.5. 0.12 divided by 0.5 gives me 0.24. So 0.24 is my height. Again, just using what I'm given to be able to write two separate equations. These bases and heights go together, and then here, these bases and heights go together. I'm looking for them, again, it's a side, and then the height is going to be always perpendicular to my side. So with the second ones here, I want to do the same thing, so I want to find that height. And so what I'm going to do is, I can go ahead and I'm going to draw on there. There, that's going to be my height that I would like to find. And so again, when I'm looking at these, I know that this is the one that I want to use, so that's my height, and again, perpendicular to that height, it's going to end up being this side, or if I really wanted to, I could say this side as well. Remember, with parallelograms, opposite sides are equal to each other, so I know that the 7 and the h go together, so I know that area is equal to 7 times h. And then the other ones that go together, again, this is my height right here. I think it's easier to do that one first. And then here is going to be my other side that is going to be perpendicular to that. Or I could do the top side knowing that opposite sides are going to be equal. And so then I can know that the 15 and the 5 go together as well. And so again, this one is going to be the one that I'm going to simplify because I only have one variable. So I do 15 times 5, that gives me 75. And then I can grab that and plug it in here to get 75 is equal to 7h. Divide both sides by 7, and I get 10.71. These are centimeters. So my height is 10.71 centimeters, and this would be square centimeters because it's talking about area. This next one, again, same type of thing. I want to find the other height. So I have one height, so I'm going to, oops. Still, it looks, there we go. So this is going to be the height that I want to find. We'll name this h. And so again, when I'm going through this one, this is my height. And so again, perpendicular to that height is going to be this side right here. Make it an L, or what it looks like there. And so I know that for this one, I know that my area is going to be equal to 8 times h. For the second one, again, finding the others, I look at my other height that I have here, which is going to be this 6 right here. And I know that one's going to be perpendicular with this piece right there, again making an L, and so I know that the 10 and the 6 will go together. So my area is equal to 10 times 6. So my area is equal to 60. I can grab that 60 and plug it in here to go 60 is equal to 8h. Divide both sides by h. I need to show that probably. 60 divided by 8 gives me 7.5. My height is 7.5. And these are centimeters again. And these are square centimeters. On the back side of the notes, we have area of a triangle. These will take us back to a little bit of trig like we did in the first semester. Remember that with trig, I've got the SOHCAHTOA to remember. Remember that this one is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so when I'm doing this problem, again, with this one, the area of a triangle, 1/2 base times height, or base times height divided by 2. And then I've got these two sides are perpendicular to each other. So those will be my base and my height. Choose a side, and then I've got to go perpendicular to it. And so I know that the base is 8. I just need to figure out what this b is right there. And so when I'm doing this, I can use trig. So going from the 25-degree angle, b is opposite, and 8 is adjacent. And so I can go tangent of 25 is equal to opposite, which is b, over 8, which is adjacent. And then to solve, I always multiply both sides by whatever's on the bottom, which in this case is 8. 8 times the tangent of 25 gives me 3.73. These are meters. Once I'm there, then I can find the area by doing 1/2 times my base, which we're going to say is 8. Again, any side. And then the height, perpendicular to, is that 3.73. So 0.5 times 8 times 3.73 gives me 14.92. And these are meters squared. Same thing with this one right here. What I can actually do is, with an isosceles triangle, I can, drop down a tangent line, and that'll always bisect this piece right here. Triangles are congruent triangles. They're equal to each other. And so if the whole bottom right here, this entire thing is 14, I know that each piece right here is just going to end up being 7. And then I know this is going to be my height, again, perpendicular to that side, and so I can use trig again. So I want to find out what h is. I have 7, and I want to go from this 20-degree angle. So again, this is opposite, this is adjacent, so I'm going to go tangent of 20 is equal to h over 7. Multiply both sides by 7, cancel out, and get 7 times the tangent of 20, and that gives me 2.55. Once I know that that's my height, then again I can find the area by doing 1/2 times the base. Remember, when I'm finding the area of the entire thing, this entire thing is my base, so the entire thing is going to be 14, and then my height will be this 2.55. Sorry, ran out of room. 0.5 times 14 times 2.55 gives me 17.85. Oops. These are square centimeters. And then the last problem on the notes here, I just have a shape that's made up of 2 different shapes. And so pretty easily I'm just going to find the area of the 2 shapes. So I'm going to find the area of the square. Again, square is a parallelogram, so I can do base times height, which is 6 times 6. Or, you know, the area of a square is, area formula is just my side squared. So I get 36 square inches. And then find the area of the triangle. The area of the triangle, again, is 1/2 times my base, which in this case is going to be 6 times my height, which is 8. So the area of the triangle is going to give me 24 square inches. And then I can add these 2 together. When I add them together, I get the area of the entire shape, which ends up being 60 square inches. Composition shapes we can do just like that.